Okay, so for concept 26, we're graphing simple inequalities. And inequalities work just like equations, but they tell you whether one expression is bigger or smaller than the expression on the other side. So it's just a comparison of two things, like less than. 2 is less than 3, greater than 5 is greater than 4. Greater than or equal to, less than or equal to. These are all inequalities because they're saying that things aren't equal. One's bigger or smaller than the other. When we use these inequalities, we can graph them based on what we're given. So for example, if I have x is less than 3, I want to find all the numbers on this number line that are less than 3. And how we would do that is two things. We would use a circle, whether it's going to be open or closed, and then we use an arrow that's going to point left or right. So if I give this example, x is less than 3, when it says less than or greater than, we use an open circle, and it looks like this. So it looks like an open circle, and the cool thing is the inequality sort of tells us where to draw the arrow. So the inequality looks like the tip of the arrow, and it tells us the direction. So if I draw my inequality and I put a line in it to make an arrow, I know that it tells me that my inequality needs to go to the left. So it looks just like that. On the other hand, if I'm working with something like x is greater than -1, I'm going to put an open circle on -1 again, and then my inequality looks like this. And if I put a line to make it look like an arrow, it's telling me to go to the right. So I would go to the right. Now, these arrows and circles tell us what numbers fit the inequality. Like, for example, 2 is greater than -1, right? 2 is greater than -1 on the number line. So is 5. Now, -1 is not greater than -1 on the number line. That's why the circle is open, because it doesn't fit the inequality. -1 can't be greater than -1 because it's the same number. And so there's times where the number can be equal to the number that you have for your inequality, and that's when we have closed circles. So when we have a closed circle, like x is less than or equal to 4, the only difference is that we are going to have a closed circle where it's filled in. It's going to look like that. And again, my arrow tells me, or my inequality tells me to draw my arrow that way. So I'm going to draw an arrow going to the end of the graph. Now, when I'm looking again for the numbers that fit this inequality, what values of x are less than or equal to 4? Well, I know 4 is equal to 4, so that's fine. 3 is less than 4, 2 is less than 4, 1 is less than 4, so on and so forth. So all of these numbers, including 4, fit the inequality. If I do this process again with x is greater than or equal to -2.5, I would put a circle on -2.5, and I'm going to close it. It would look like that. And again, my inequality looks like this, so I know I'm going to put a line going that way to the right. It looks like that. So they're open when there's no line under it, and it's closed when there is a line under it. And then the inequality direction tells you which way to draw the arrow. Let's take a look at a couple examples. So you'll notice that in the previous problems above, the x is always on the left-hand side. So whenever we're graphing, we need to make sure the x is always on the left. And how we do that is we switch the inequality around. So my x and my -8 need to switch places. But what happens is that the inequality changes direction. So it changes from this to this. So when we do that, like if I were to graph it, I now would graph this one. So x is less than -8. I know it's going to be an open circle and go to the left, less than left. Similarly, I would switch the place of the variable and the number to make sure that my variable is always on the left. And I also need to change my symbol from this one to this one. And then I would graph it. So 11, 12, 13. I know it's going to be a closed circle on 12. And it's going to go to the right. If I'm going the other way, where I have a graph and I need to write an inequality for it, I would do the same process, but just in reverse. I know I'm going to have a variable, and my circle is on -7. I know that my arrow points this way, and it's an open circle, so it doesn't need a line. So I'm done. I don't need to write anything else. But on this one, for example, on number 4, my number is on 2, and it's going to the left. My arrow is going to the left, and it's a closed circle, so I need to put a line underneath. And that's that. A couple word problems. As an example, these words represent the given inequalities. Is less than, greater than, less than or equal to, greater than or equal to. And there's sometimes other bits of language that could represent the inequalities as well. So for example, for number 1, it says that Anthony is shopping for a birthday gift for his cousin Robert, and he has $25 in his wallet. So it says write an inequality that shows how many dollars he can spend on the gift. So if he has at most $25, right? He can spend $25, but he can spend less, but he can't spend any more than that. So what we would say is it's either at most or no more than. No more than. And what that says again is that it could be $25, it could equal $25, but he can also spend less than $25, less than $25. So we would use this inequality. If we wanted to do it again, for number 2, it says Teresa is only allowed to swim outside if the temperature outside is at least 85 degrees. So we don't have at least in our table up here, but you can think about it like 85 is the lowest it could be. So it could be 85 or greater. So that's essentially greater than or equal to. So whenever you see at least, you know it's going to be greater than or equal to. You can also say no less than. You'll see that as well. So for this problem, we have x and 85. Well, I know it could be 85 or greater. That's why we use the greater than or equal to inequality. And that's that.